All right, so this was our first starter questions here for today, which is graphing simple polar equations by hand. And we're doing a little review because if you don't know how to graph this point, how are you going to graph a whole set of points like that? So here's where 5 comma pi over 2 is. Give me directions like I'm a small child. Regular 5 comma pi over 2. Where's that?
So then I went and found pi over 2, which is in between pi and 0 pi, so it'd be...
I agree. So up here somewhere, right? Okay. And then, but then we can't stay there because the original question was negative 5 comma pi over 2. So what do I do?
I would flip it all the way down to the bottom.
And that's the way I teach this. Yeah, you go down here to the opposite side, and there it's right there. Now again, some people teach this differently. They say to go to negative 5, which would be here, and then they say to rotate pi over 2 in that direction, which would get us to the same exact spot. Okay, raise your hand if you graphed that one properly. Okay, excellent. Now, if I asked you, what's the cosine of 2 pi over 3? I know this is not what we just did, but it's related. You'll find out. Cosine of 2 pi over 3. I bet about half of you are going to get this wrong. Draw it in circle trig. I'm noticing that a ton of kids have forgotten something important. It's 1/2. Right? No? How dare you question the teacher? What did I do wrong? That's a negative right there, so it's negative 1/2. That's going to come up today during our graphing. Is you're going to have to remember cosine's adjacent over hypotenuse, right? And that's a negative 1 right there. And if you forget that it's a negative, you're going to forget that the answer is negative 1/2. And obviously, that's quite different than regular 1/2. And so be careful with that. All right, that's just a side step because I know what's coming. All right, so now here, polar to polar to rectangular or rectangular to polar. So let's start with somebody who's actually here. Ryan Fries, can you tell me how you would have done the black one here?
I would multiply by r on both sides.
I like it. Could you have squared it?
You could,
yes.
It'd be easier if you multiply by r.
I agree. Okay. So now r times r makes r squared, which again begs the question, why didn't you square it? Well, this would have been 2 cosine quantity squared, and instead it's just 2r cosine. Why is that so nice, Mr. Freeze?
Because cosine theta r is equal to x.
Because that's just x. And the other one? Ben?
X squared plus y.
And then what don't we have to change, Ben? Boom. How do I know I'm done with that, Jack Sand?
Because there are no r's or thetas.
All right, excellent. This one is in rectangular. You're converting it over. Murph, you know what to do.
Because y over x equals that equals tangent.
You got it. That one changes. I like it. Do you remember what x squared plus y squared changes to?
That could be r squared.
There you go. Do you feel like you have got it changed all into polar?
Yes.
I agree. It's only r's and thetas left. Now, some people were like, but why is r sine theta? So I did that, and cosine's r cosine theta. But think about it. Wouldn't the r's cancel? And then wouldn't sine over cosine be tangent? So it still works. Math always ends up coming around to working. It just sometimes you can't see why it's going to work. So this would have been fine. It just didn't simplify it all the way. And there it is. Okay. So we are going to just remind you that a calculator can graph things, but and I'll show you later how to do that, but we need you to be able to graph things like r equals sine of theta with just you and your brain and a stick and some sand, or in this case, your iPad and your finger. If you wanted to graph this, tell me how you'd start. I gave you a taste of it yesterday, just a little beginning. Well, let me ask you this. If it was y equals 2x or something, what could you do that would be the same now and then? Like in both cases, it would work. What are you thinking, Melissa?
You could pick an angle for theta and solve.
Yeah, it's kind of like an XY chart, but you're going to pick a theta and then figure out what the r would be. Do you get if I pick theta to be 0, then I can find that the point would be r equals sine of 0. How am I supposed to know what sine of 0 is, though? Oh, you're supposed to know that. Let me ask you and strongly encourage you to write these down somewhere. You need to know all your quadrantals, which was best remembered in the unit circle. So this is 1 comma 0. This is 0 comma 1. This is -1, 0. And this is 0 comma -1. And now if I say what's sine of 0, you can just be like, oh, there's 0. Sine's the y. Y of this is 0, so sine of 0 is 0. So r equals 0. So there. All right, now let's try another one. So I just, oh, question? Ooh, there might be a second answer. Interesting point. Okay, I'm trying to figure out what we were doing though. Okay, here's just to clarify. We were not doing sine of what angle would equal 0. We were just asked sine of 0. Know what I mean? So sine of 0 means you are at this spot right here. Are you over here when you do sine of 0? No. See, there's a difference between sine of 0 and sine of some unknown angle equals 0. This would have two answers. This is just one thing. What is sine of 0? Sine of 0 is only one thing. Okay? Like if you type that on your calculator, you type in sine 0, enter. It's only going to give you one thing. Okay. All right, so 0, 0 is one of my points. So everybody, I hope you can graph that. Think about a radius of 0. You start at the origin and then you don't move. So that's 0. Okay, cool. We got a spot. Now, big picture. Does anybody have a short-term memory? Last 24 hours, I told you generally where the answer was going to be. For sine, they're generally somewhere, and for cosine, they're generally somewhere. I saw you taking notes yesterday, which means it's stuck in your head better. Or you just referred back to your notes. Either way is okay. What do you think?
It's in the first two quadrants.
Yep, sine is generally up in here. Do you remember what's generally where cosine is? You remember?
I think it's in quadrant 1 and 4.
All right. Like that? You are correct. Now, if you're like, geez, how did these guys remember that? Here's what would have probably worked. Had you written that down and taken notes on it, it would have engaged a different part of your brain, which would have meant you would have been the kid who remembered it right there. Now, some kids are that good at auditory memory that they can just hear me say something and they'll remember it. But that's rare. Much, much more likely if you write it down. Okay, so anyways, I just said generally speaking the answer should be up above the origin, like the blue one for sine. So let's finish it off and see where it actually ends up. Big picture again. I like to talk about the big picture so you don't just get lost down in the complicated little details. Do you get, I'm going to get a bunch of points and they're going to kind of look like this. Do you see what I mean? And then, oh, what shape do they make? Oh, it's a circle, okay? Now, how do I get those points again? By picking any random angle. Let's say I want to take that angle right there. What angle does that look like to you? 45 maybe? Okay. Well, then let's do the angle pi over 4. And let's see where the dot ends up. And by the way, if it comes out to a negative number, we'll have to shoot over this way instead if it gives us a negative r. Okay? All right. So, pi over 4. I'm now going to do the work I would, you don't have to show this right now, but this is what you are doing. R equals sine of pi over 4. And then I'm hoping you're going to go, dang, pi over 4 is not on this chart. How would I get the sine of pi over 4? Remember it? Remember how to do it, Hagen? What do you do? Correct. 1, 1, square root 2. And therefore, I can do any of my 45-degree angles that way. And I can pick either angle because they're going to be the same. And so I'll pick this one. And so sine is opposite of hypotenuse, 1 over root 2. So my answer is what? 1 over root 2? Yes, it is. And I know that's kind of gross. So what the heck is root 2? I told you there were two that you're going to want to know. Root 2 and root 3. Because they're decimals that you're going to have to graph by hand. How are you, unless anybody in here is like, oh, I know where 1 over root 2 is. Like, how far out do I go? If the radius is 1 over root 2, how far is that? Now, if I said to graph 0.6, would you guys be good with about where 0.6 is? Would you know where it's a little bit less than 0.5? Or I mean, a little bit more than 0.5? I mean, it wouldn't be too hard to do 0.6. But what the heck is that? All right, so here's two that you need to memorize. Square root of 2, square root of 3. I'll tell you the two answers, and I bet you'll know which one's which. It's 1.7 and 1.4. Now use logic to figure out which one's which. Because see, you're not going to remember them in the right order. Just remember one's 1.7, one's 1.4. So which one's got to be which? Mr. Sand, if they're 1.7 and 1.4, which one's which? There you go. There you go. Now memorize those because they're going to come up. Because like right now, it wants me to graph this thing, and I know the answer is 1 over root 2, but I have no clue how big that is. Now I go 1 over 1.4. 1 over 1.4. Well, is that more or less than 1? If I have 1 over 1.4. It's less than 1. In fact, if it was 0.7 over 1.4, that would be exactly half, right? So basically, this is a little more than half. I know it's an imperfect science, but you're just putting dots on a piece of paper. You're going to go about a little more than half, right? So maybe 0.6. Is it okay to put that on the, sure, close enough. If you had said 0.6 or 0.7, I'd have said that's fine. A little more than half. All right, now on your worksheet that you're going to get in a minute, I've got it labeled how far 1 is. And obviously we'd go to 0.6, which would be about half of 1, right? So we have circles on your graph paper. Now I'm going to change to that in just a minute here. And we'll start doing them when we have graph paper. It's a little cleaner. So your graph paper is like this. It's got circles like this, and that would be the 1 circle and the 2 circle. So now if I'm going to go to 1 over 1.4, it's about 0.7 or 0.6-ish. So I'm going to say it's like here-ish. Do you get how if I had been slightly off, it would have been fine? Okay. All right. Cool. That's one of my dots. Do you get there's going to be a whole bunch of dots like that? And generally, what shape are they going to make? circle. All right, let's do pi over 6 and 2 pi over 6. Yes, I know that can be simplified. Find those two next. Everybody figure out pi over 6 and 2 pi over 6. I need a new triangle. 30, 60, 90. 1, 2, square root of 3. These three things are going to be super handy today for finding the answers to things like what's the sine of 2 pi over 3, or what's the sine of 3 pi over 2, or what's the sine of 60, or what's the sine of 30, or cosine of 60, or cosine of 30, or sine of 45, etc. I hope you figured out that this is sine of 30, really, because pi over 6 is like 30, right? Sine is opposite of our hypotenuse, which is a half. Boom, it's a half. Awesome. A half. And we already had 0, 0 on here. I have a theory that there'd be a dot. I'm going to draw a green arrow to it. I bet you there's a dot right there to kind of start making my little circle. It goes up above the origin. My guess is there's a dot there. So what's that spot? Pi over 2. Would you guys figure out what the sine of pi over 2 is? What is it? It's 1. Boom. There is a dot there. See how that kind of like, I could see there should logically be a dot there if I'm going to have a half circle there. And then I'm going to continue my little half circle, and then I'll end up with dots that basically go like that. And look, Mom, I made a circle. All right, let's just do one more of those. I said to do 2 pi over 6 already, and just so you know, that would have been like sine of 60. And sine of 60 would have been root 3 over 2. And I know some of you are like, how am I supposed to know what that is? Well, I told you to memorize it. That's like 1.7 over 2. Would you agree that that's almost 1.0? A little less than 1.0? That was because we were right about here. And it was really close to 1. And it makes sense. It's right on the circle. That was this spot right here. Okay? And let's do one more. And let's do 5 pi over 6. Sine of 5 pi over 6. I'm going to draw the picture for you. Here's where 5 pi over 6 would be. Sine. Oh, it's a 30, 60, 90. 1, 2, square root of 3. Sine's opposite of hypotenuse. It's 1/2 again. And that's this guy right here. Okay, I think you got the idea. Now, I'm going to give you the graph paper where you can do this on paper. Those of you that are at home, I have put it up as a PDF. Everybody find it and pull it up. I'll do this first problem with you, and you'll be off and running. Now, I would keep your calculators out though for a minute because I'm going to show you how to check yourself using the calculator. And it'll be kind of cool. Unfortunately, I'm just going to tell people at home that are watching this video, I'm sorry I can't show you this calculator part. But if you take 2 seconds, look up a YouTube video. You can look up a YouTube video called Graphing Simple Polar Equations on your calculator. It'll show you how. And besides, this is not a skill that we even need for this test because we're not going to ask you to graph any on the test, except by hand. I just think it's kind of fun to play with. So. Okay, so we'll do a little bit more with this worksheet first, and then we'll stop the video, and then we will have the rest of the time to work on the worksheet and play with your calculator. Okay. Number 1 on the worksheet. Chloe Mack, what is it?
When you just gave us
Kind of.
R equals 2 sine theta.
2 sine theta. Oh, I thought you meant, yes, though on the worksheet I just gave you, yes. I thought you meant, didn't we just do this problem? And no, we didn't. We did something really close to it. We did sine of theta, but do you get, we're just going to have to take each of the y values and times them by 2. Now just guess then. If you kind of are smart enough to know that it's a circle up here, what do you think happens to it when you times it by 2? Yeah, the r gets bigger. It says r equals, right? So r equals a bigger circle. Okay, so it's not that complicated. All right, so let's actually get a few points though. We have a theta and an r, and I talked to colleagues about this, and even though it's normally r comma theta, it is kind of handier to have the theta on the left side just because you're putting in any angle you want. So let's put in these because, hint, spoiler alert, if you look at the key, this is what I put in on the key. I put in 0, and then I put in 1 pi over 6, 2 pi over 6, 3 pi over 6, and then maybe you want to skip a few, 1, 2, skip a few, and try like 5 pi over 6, etc. But I just do mostly pi over 6s because it's 30, 60, 90s that way. They're nice, easy triangles. And at the top of your worksheet, please, 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 for your own sake, make a 30, 60, 90 triangle. 1, 2, square root of 3. That'll remind you how to find all of the 30s, 60s. And how about the 90s and the other quadrantals? I'd put one of these at the top of your paper, 1 comma 0, 0 comma 1, negative 1, 0, and 0 comma negative 1. And then I'd make a 45, 45, 90 triangle. 1, 1, square root of 2. And now I can do any of the angles. All right, I suggested that our first angle should be 0. So then we're graphing r equals 2 sine of 0. Well, sine of 0 is this. Sine is the y part, which is 0. 2 times 0 is 0. So it's 0, 0 again. Your first point is 0, 0. Now let's put in pi over 6. R equals 2 times the sine of pi over 6. That's like the sine of 30. That's going to be this little triangle then. Sine of 30 is opposite of hypotenuse. That's a half. 2 times a half, it's 1. Are you picking up what I'm laying down here? Seeing how to make these points? Not buying it. Okay, some people are still not catching this. Let me explain this a little further. All I did was stick in pi over 6, and I could have picked any angles. I just suggested that the pi over 6s are easy. Okay, so here's how I did 2 sine of pi over 6. First of all, sine of pi over 6, I find that, and then I just double it, right? So sine of pi over 6. This goes back to the most basic trig, which is I got to just find sine of 30. I know pi over 6 is like 30, right? So this is like 2 times, and again, sine of 30 is 1/2. So this is r equals 2 times 1/2, so r equals 1. That's how I knew to put in the r column. I knew to put a 1 right there. All right, 2 pi over 6 is the same as pi over 3, which is really a 60-degree angle. The only time this can burn you, pay attention now, when they say like 2 pi over 3, do you get 2 pi over 3s is going to be here? And all of a sudden, if you're doing cosine in that quadrant would be negative. Do you get what I mean? If you're just grabbing all your numbers off of these, do you get none of them are going to give you negative answers? You got to be aware that if you're in quadrant, quadrant 1 here or quadrant 2, all of a sudden, anything in quadrant 2 that's cosine or tangent is going to be negative. So you got to give negative answers. Let me warn you that about halfway through problem 2, you start getting negative r's. So maybe make that note on the side of the worksheet. Halfway through problem 2, you're going to start getting negative r's. So beware, if you're doing angles that aren't in quadrant 1, a lot of times the answers are negatives. Okay, now there's a key. The key for this worksheet is already posted, but I encourage you to not go look at it like and know what the answer is ahead of time. I would look only after you are getting extremely concerned about if you're doing it right. Okay? All right. Now, there's one extra on the back side of the worksheet. Everybody flip the worksheet over the back side. Do you get that there is an extra graph on the back? That's an extra one in case you screw up one of your graphs so bad you can just try it over again. Okay? All right. So there's only 3. This is doable. You should have seen the other one that I could have assigned. You had to graph things like number 2 and then have another one on top of it intersecting it and then tell where the intersection points were. Holy crap. Way too much for one day. So I'm glad I backed off. So this worksheet is the only thing due tomorrow. And that's all I have for the video for today.